See, the next question is like y equals to e raised to the power 2x over x square. Again, we need to differentiate it, and what we can see, this is again the quotient rule, u upon v, and we know that the concept is it will be v square. We know that now, and this is v, the
Yeah.
derivative of u over dx, then minus u is taken out, and then this is dv over dx. This
Yeah.
is the concept. So now if I do this, this is dy over dx, square of the denominator, x square whole square, x square is taken out, and then the derivative of e raised to the power 2x over dx, then minus e raised to the power 2x is taken out, and the derivative of x square over dx.
Yeah.
So this will be x square, the derivative of e raised to the power 2x is 2x, e will be as it is, then the derivative of 2x will be 2, then minus, this is e raised to the power 2x, and x square will be 2x.
Yeah.
Divide by this is x raised to the power 4.
Mm.
Got it?
Yes, sir.
Now, if I do the calculation, what I can take e raised to the power 2x times 2x as out, right? This will be x, and this is minus 1
Yeah.
over x raised to the power 4.
Yeah.
Got it?
Yeah. Now you can just equate it to 0. तो अपना stationary point 1
Yeah.
बनेगा.
To get the stationary point, we can do dy over dx equals to 0.
Yeah.
If I do so, this is e raised to the power 2x times 2x, and x minus 1 over x raised to the power 4 equals to 0. This will cross multiplied. So
Yeah.
this term will get 0, and then we will have e raised to the power 2x times 2x, and this is x minus 1 equals to 0. Now this is a positive term. Which is a positive term? This is a positive term. So we can transfer it here, and that will be 0. Now we are left with x times x minus 1 equals to 0. If I see this, this will be now x equals to 0, and then x minus 1 equals to 0. So x equals to 1. We got 2 points, x equals to 0 and 1, right? But what is
Why
the...
are we just using?
Yeah, tell me.
We're only using one of the coordinates. We're only using x is equal to 1 wala coordinate.
Yeah, I will give you the reason like why we are using only one. See here. But x should not be 0. X should not be 0. Why should not be 0? Because if x becomes 0, the curve will not get defined. Are you getting my point? This is my question. And if x comes out to be 0, the equation
Yeah.
will not get defined. So you should know reason like why we are not using. We have the 2 points. Sometimes we have to use it. So
Yeah.
that's why. X is not 0. We'll write it because the equation
Won't be satisfied.
not defined.
Not defined. Yeah.
Not defined for x equals to 0. Fine. So therefore we'll be using x equals to 1. So y will be e square raised to, and this is 1, so it is e square.
Yeah.
Now therefore the stationary point we got, so
1 e square. 1 comma e square.
stationary point, x coordinate is 1 and y coordinate is e square, 1 comma e square.
Yeah.
Fine.
Need to
Now,
double differentiate.
yeah, we need to double differentiate it. So what we had dy over dx was the simplify, what was that? It was 2x square e raised to the power 2x minus 2x e raised to the power 2x over x raised to the power 4.
Yeah.
Now for the second derivative, dy d2y over dx square, the same concept, let's square the denominator. We will take the denominator out and the derivative of the numerator. Right.
Yeah.
If we do the derivative of the numerator, so what it will give me? What it will generate? The derivative of the numerator, this one. So can't we write it like this way? E raised to the power 2x times 2x and then x minus 1.
Yeah.
Yeah, we can differentiate it,
Yeah.
and this is over x raised to the power 4. So the derivative of this term, but it is again complicated.
By
It is again complicated, but we need to do that. Let's take e raised to the power 2x. We need to simplify it. Okay, the better way, because it is a little bit complicated, so better way is that we can simplify it firstly. What we do, let's do the simplification. How we can do that? We can do it like, let's take 2x square e raised to the power 2x divide by x raised to the power minus again 2x, then e raised to the power 2x divide by x raised to the power 4. Fine. So we can cancel it out. This is x square, and what it ends up, this ends up like 2 times x raised to the power minus 2 and e raised to the power 2x. Similarly, this 2 will be there and this will get cancelled, so this will be x raised to the power minus 3 and this will be e raised to the power 2x. Fine.
Okay.
And if I take this e raised to the power 2x as a common, and then it will be 2 x raised to the power minus 2, and this is minus 2 x raised to the power minus 3.
Now you can use product.
Yes, this is dy over dx. Now we can use the product rule, that is far better. So this will be d2y over dx square. We can take this term out first, like twice of e raised, wait, this is twice of x raised to the power minus 2 minus 2 x raised to the power minus 3 is taken out. What is this? Is u and v, product rule. So one term is taken out and the derivative of e raised to the power 2x is e2x, and 2x will be 2. Then we have a plus sign, and then e raised to the power 2x is taken out and it's easy to differentiate it. So this 2 will be there as it is. This is going to be minus 2 and x raised to the power minus 3 and x and minus 1. Now similarly, this minus 2 will be there. This is again n, and it will be x, then n minus 1, so this will be minus 4. So if we simplify it, now this is going to be this 2 and this 2 and this 2, so that will be 4. Got it? And this is e raised to the power 2x, and then we have x raised to the power minus 2 minus x raised to the power minus 3. Same case here, this is minus 4 and this is plus 6, right? So this is e raised to the power 2x and this is minus 4x raised to the power minus 3, and this is plus 6x raised to the power minus 4. So this is going to be 4 times e raised to the power 2x. This will be as it is, this is as it is, and this is plus e raised to the power 2x. We can take 2 out from here, 2 out from here. So this will be minus 2x raised to the power minus 3 and then plus 3x raised to the power minus 4. Now what we need to do, we have to check when x equals to 1. If I put x equals to 1, so this will be 4, and what we are checking for? Second derivative, d2y over dx square. So this is x equals to 1. So this 4 will be as it is, e, and this is times 1, this is 1 minus 1 plus this is 2, e times 1, this is negative 2 and this is a plus 3. So this term is 0. and this term is 2 e raised to the power 2 as it is. Fine.
Yeah.
And what we can see, the second derivative is positive because this is simply 2e squared and that is greater than 0.
Yeah.
And we know that when the second derivative is positive, so
Yeah.
this
Point.
is
Yeah.
this is a minimum point. Okay.
Yeah.
Where you got stuck?
Sir, I got stuck because I didn't convert it into product rule में. मतलब मैं उसको क्वेश्चन रूल से सॉल्व करने की कोशिश कर रही थी एंड दैट वाज टू लेंथी. ईच पार्ट ऑफ इट मतलब अलग अलग सॉल्व करना पड़ रहा था, तो आई थिंक उसमें कैलकुलेशन एरर हो गई, काफी लंबा मेथड बन गया था. बट या दिस इज समथिंग वी कैन डू इफ वी डोंट गेट इट बाय क्वेश्चन रूल, तो उसको कन्वर्ट कर सकते हैं, राइट?
Right. We can convert it to product rule, and product rule is easy to use.
या इट्स इजियर कंपैरेटिवली.
You got it now? This is understood?
यस सर.